So first we'll calculate reaction forces. Okay, so let us take this as a RA and this is the RC, right? RA and RC. Okay. So now we'll go for reaction forces. Okay. So let us take a moment about A and equate it to 0 for equilibrium condition. Okay. So what are we going to get? So if we convert this UVL into point load, let us go for conversion of the loads here. Okay. Now this is what a point A. Now point B, it has a 20 kilonewton as the external load. Okay. Again the converted UDL load. This is what 6 into 10. Okay. This is exactly the distance of 3 meter. This is exactly the distance of 3 meter. So you have a reaction support here RC, so which is at an distance of 6 meter. Okay. Now convert this UVL into point load. Convert this UVL into point load. Right now this is a 30 kilonewton per meter here, and this is the height 2 meter. So now this is what 30 kilonewton is the converted point load. Now position is from fx, it is 2 by 3h. Okay. Now we are going to get this point load here. Now distance is how much here? Is 2 by 3. Okay. Into 2. 2 by 3 into 2. Now let us write equations and simplify to get the value of RA. Okay. So now here 20 into 3, okay, plus 60 into 3 plus 30 into 2 by 3 into 2 plus 6 equal to RC into 6. Now we calculate value of RC. Now we calculate value of RC. So how much you get? So how much you will get? Yashwantara, other screen is visible or not? नेट हो गया सर. So is there anybody calculated reaction force
56.66.
on which side?
RC.
56 point
Sir, 46.6.
46. How much? 46.
0.66. Kilo.
Next, RA. RA equal to, okay. So 20 plus 60 plus 30 minus 46.66. Now 20 here, it is a point load, okay. 60 is UDL, okay, and 30 is UVL, okay. Now these the loads are acting in a downward direction. So now we calculate RA. So now we calculate RA. Whether this is right? Is it correct?
Yes, sir.
Okay.
Yes, sir.
Now let us go for a calculation of shear forces. You calculate the correct. Now they have given RC 76.7. How you have calculated? Check it. Whether all equations are right here. So now 20 into this one.
Sir, RC 76.66.
76 point.
66, sir.
Right. Okay. 76.66. Now you are going to get 33 here. Okay. 33.34 kilonewton. Now we'll draw the diagram. Okay. Now calculate the shear forces. Okay. Now I'll go for first at point A. This is how much? 33.34 kilonewton. Okay. Now shear force at B, which is 33.34 minus 10 into 3 minus, sorry, plus 3.34 kilonewton. Okay. Now this is what before consideration of the point load. So let us consider the point load here. Shear force to B. If you are confusing, now we go for considering point load. Okay. Considering point load plus 3.34 minus 20 minus 16.66 kilonewton. Okay. Now Now at point C, how much you are going to get? Okay, so shear force at C. Okay, now this is equal to 33.34 minus 20 minus 60. How much you are getting? How much? Hello?
Minus 46.66, sir.
46.66 kilonewton. Okay,
Minus.
minus, right. Okay, so now let us consider shear force.
Sir, 10 into 6 sir.
Pardon?
10 into 6 sir. ಇದು UVL.
Now it has been written directly 60 here. Okay, 10 into 6, 60. Okay, this is point load. This is a reaction
SF
force.
sir, SF at B ಇಲ್ಲ sir.
Except at B, you will get a minus 16.66. Now you make a portion here because this distance is 3 meter. Okay, this distance is 3 meter and
Yes sir.
this distance is 2 meter. Right?
Yes sir.
Now shear force at C, when it comes into effect of the reaction force, this is what, minus 46 plus 76.66. Now how much you are going to get here? This is 30 kilonewton. Okay, this is 30 kilonewton. Now it is going to be there, shear force at D. It is going to remain 30 kilonewton. Right? So now we'll draw the shear force diagram here. So here we are drawing as an got the value. Okay. Now let us go for, now this is A. It is how much? Now this is 33.34. Okay. Now here we are getting a 3.34. Then you are getting minus 16.66. Okay. Then you are getting minus 46.66. When you consider the reaction force, it is going to come 30 here and it's going to remain 30. Okay. This is what a positive. This is a negative. This is positive. Right? Okay. Now let us go for calculation of bending moment. Let us go for calculation of bending moment. Okay. Okay, so we can consider section from left hand side. Okay, so as you're familiar with the considering section from left hand side, let us consider section here. Okay, now let us take this section x. Now general equations you can write. So bending moment at section x. So MB x equal to, okay. So now this is what a RA, this is RC, okay. So x into RA minus, okay, minus. So 20 into x minus 3. This is related to the point load, okay, minus, okay, 10 into 6. Is it right? 10 into 6 x minus 3, okay, x minus 3. Now this is what a converted UDL into point load and its distance and its position. So now it is x minus 3 minus, sorry, plus RC into x minus 6. Okay? RC into x minus 6. Again minus, okay. So you need to find out what is the position of what you can say the value of UVL at this particular section. Okay, this is equal to what? You are going to get a two symmetrical triangles here. This is the value of x. This is the value of what? X minus 6 here. Okay. Now you have a symmetrical triangles here. You have a symmetrical triangles. This is 30 kilonewton. This is what 2 meter. Right. You need to find out. You can say Wx here. You can say Wx. So how are you going to get here? Wx divided by x minus 6 equal to 30 divided by 2. Okay. So now Wx equal to 30 divided by 2 into x minus 6. Okay. This is what? Load of UVL. Okay. Into. So if you consider CZ here, if you consider CZ, now that CZ is what? X minus 6 by 2. Okay. Into x minus 6 by 2 by 3. Okay. From fx it is a 2 by 3. Is it clear how we have got these two equations? Now this is what Wx. Okay. Now this distance is what? It is x minus 6. Okay. Right. Now how you got a value here? W by 30 into 2 divided into x minus 6. You are going to get a Wx here. Okay. Wx. Now position of this one is this much portion. That means from fx is a 2 by 3 x minus 6. Now you got a load here. You got a load at this variable point. Now the point load of UVL, this is equal to what? 1 by 2 B into H. Okay. So 1 by 2. Breadth is x minus 6 here. Okay. So W is 30 by 2 x minus 6. Okay. Now to get the moment, you need to multiply 2 by 3 into x minus 6. X minus 6. Okay. Now I will rewrite the equations clearly for calculation of bending moment for this UVL load. For this UVL load, you got Wx is this portion. Okay. Now you need to find out point load. That means UVL has to be converted into point load. How we are going to convert 1 by 2 into BH? P is Wx here, okay? So H is x minus 6. Now B is 30 by 2 into bracket x minus 6, right? This is what B. H is here, it is what x minus 6, okay? But to get the movement, you need to multiply the distance here. You need to multiply the distance, okay? Now, I'll write here Ra into x minus 20 into x minus 3 minus 10 into 6 into x minus 3, okay, plus, so Rc into x minus 6, okay, minus, now just look at, now I will write point load, okay, and okay, 2 by 3 x minus 6 is this position. Let us take this as a position of CZ from fx here into converted point load. This is what 30 by 2 in bracket x minus 6, okay, into B is x minus 6, okay. Now this is the equation, okay, this is the equation. Now let us go for calculation bending moment at point B, okay, calculation at bending moment point B. That means you need to consider this much portion only, okay, this much portion, right? So you can write a general equation, then you go for substitution, or if you're getting confusion to write the general equations to calculate the bending moment, you can calculate at individual points, then you can rewrite those points, okay. Now let us look at, now we are going for an individual points here, we are going for a individual points, right? Now in this case, what is the bending moment at B? Now Ra into 3 minus 10 into 3 into 3 by 2. Now someone calculate how much you are going to get. Someone calculate how much you are going to get. If you are getting confusion to write the equation for calculation of bending moment, you can individually calculate the bending moments at the particular points, then you summarize them, right? How much you got here? Am I audible or not?
Yes, sir.
Now calculate how much you got.
55.02, sir.
Okay. Next, bending moment. Somewhere I'll take a one more point here. Let us take this point as E. This is how much? It is 1 meter from point B. Okay, 1 meter from point B. Okay? Now, right? This is the diagram. Now let us write here. Okay. So this is what array into 4, okay, minus this is what 10, okay. So 10 into 4 by 2 minus 20 into 1. So array is how much? 33.33 into 4 minus 40 into 2 minus 20 into 1. Now we calculate how much you're going to get.
Thirty-three point three two.
How much?
33.32.
Okay, now let us calculate bending moment at C. No. So let us write equation here. So RA into 6, okay, minus 10 into 6 into 6 by 2, okay. So minus 20 into 3, okay. So now you calculate. So RA is 33.33 into 6 minus 60 into 3, okay, minus 20 into 3. Now how much are we going to get here?
Minus 40.02, sir.
Minus
40.02.
now sign changes is done here, okay. So the bending moment has made sign changes, okay. So at point E you got a positive value, okay. At point C you got a negative value. Is it right? Okay. Now so let us bending moment at free end D, that is 0. Okay. Now let us go for drawing the bending moment diagram here. Let us go for drawing the bending moment diagram. Okay. So now I will draw a bending moment diagram. Okay. So now at this point, how much you got? At this point, how much you got? At this point, it is a 0. This is also 0. Okay. Now, as a combination of what I can say, the UDL and point load. So you are going to get the bending moment here, and it is going to make a sign changes, and we are going to get a bending moment. Here it is of a UVL nature. Okay. Now this value is a negative, and this value is a positive. Okay. Now bending moment made a change in its sign at this point. Made in change made a change in sign at this point. Okay. Now this point is about A, this point is B, okay, this point is C, and this point is D. Now you got a bending moment maximum B. I think how much you got a maximum bending moment at point B is point B. It's a 55.02, right? Okay, and you have gone for one point, that is what a E point, to check its feasibility. How much you got here? You got 33.34. 33.34. So now here you got a minus 40.0. Now let us find out what is the point of counterflexure here. Point of counterflexure. Okay. Okay, now we'll draw the diagram for that point of counterflexure. You can just look out. Now let us look out. RA into X, okay, minus 20 into X minus 3 minus 10 into X by 2. Now equated to 0. RA is how much? 33.3634. X is unknown. Minus 20X minus 60 minus 5x squared. Now you simplify, you find out
Plus
value of
60.
x. Huh? Pardon?
Plus 60.
Okay, plus 60, right. Now you find out value of x here. I think you're going to get quadratic equations here. So use minus b plus or minus square root of b square minus 4ac divided by 2a. Okay. Use this equation. Okay. Now you rewrite this one in the form of here. You check it what are the signs, and it is going to associate. Okay. Otherwise you go for this as a x. Okay. Now find value of x. So how much you got x? Hello.
Sir, 5.04, sir.
5.04.
04.
Okay. Now I hope the problems for shear force and bending moment are sufficient. Now I'm going to close this chapter. I'm going to start a new chapter. Now we have any doubts or any problems? If you have any problems or you have any doubts over shear force and bending moment diagrams, or you have any confusions or you have any problems, feel free to discuss. I'm going to close this chapter. Hello.
Yes, sir.